Number 6, find the area between the graphs of r equals cosine theta and r equals 1 plus sine theta. So this one's going to be different than the last one. You see, as soon as we get into the graph, so let's plug it into our y equals or r equals here. We've got cosine theta and then 1 plus sine theta. And then I've got the window set up. I think it's going to be okay, but we'll graph it just to make sure. Looks good. So we're looking for, as far as the area in common, it actually says the area between the graphs of, and it's still, again, it's where are they overlapping. And we've got this cardioid that comes up like this, and then we've got this circle that's in here. That looks, sorry about my awful drawing. That's awful. I have to start over. I can't handle it. In fact, I'm not even going to try it again. I'm going to try to, oh, I don't think I can bring it over here. Oh, maybe I can. There we go. Okay. So, much better. What we are looking for is we're looking for all of this area right here. Now, if I kind of zoom in on that, what we've got is we've got no symmetry in this one. And we've got the cardioid that is down here. And then we've got a circle that is up here. Okay? And then we've got to find the area of that. But we're not going to use any symmetry. What we have to do is find the radial lines that go through these two intersection points for both graphs. And so if I'm doing the circle here, I'm looking for this radial line and this radial line. So I'm going to trace this graph. So when I hit trace, again, I check the top of the calculator, is it the curve I'm looking for? And it's cosine of theta. And then I arrow over till I get back to the origin. And I went way too far. We're at 0, 0 at pi over 2. So that means we go from 0 to pi over 2. That is going to get all of this area. So I'm going to do 1/2 times the integral from 0 to pi over 2 of cosine of theta squared d theta. I know that. I've got to add to the area of this part that's below. So now I'm going to switch over to the other graph. Now you'll notice I switched over, and at 90 I'm up at the top of this graph. I need to get around this graph and get back to the origin and back to the 2 points that we need, which are, I'm talking about these 2 points here. We need these 2 points if we're going to get that area. So I'm going to arrow around until I get back to the origin. Looks like I'm back at the origin now. It's 270. So I've got a radial line at 3 pi over 2, and I've got to get back to this radial line. So I'm going to keep on going until I get back to the other intersection point, which is at 360. So that's going to be at theta equals 2 pi. So this other integral will be 1/2 times the integral from 3 pi over 2 to 2 pi of 1 plus sine theta quantity squared d theta. And then this just needs to be plugged into the calculator, calculated in radians, and the value of the answer is 0.571 0.5708, whatever works.